So we're just going to look at this example. So let me share my screen. Very straightforward. We've got this diagram shows a sketch of the curve with the equation y equals 2x squared minus 5x plus 2 in brackets e to the minus x, which since brackets means multiply, this means this is the product of the two functions. The two things are being multiplied. Can you both see that okay?
Yeah.
Yeah. So that's the graph of the sketch of that function. So part A, it's just quite straightforward intro. Find the coordinates of the point where the curve crosses the y-axis. So what would we do to find where it crosses the y-axis?
We want to find where x is equal to 0.
Yeah, exactly. We're going to set equal to 0. Yeah. So if we set equal to 0, what does y equal?
Uh, 2e minus 2.
2e. Remember what's x equal to?
Oh, right, 0, 2. Right.
Okay, what do you think, Rahat? What did you get an answer?
Sorry, 1 second.
Would it just be 2?
It's just 2. Yeah, oh, Rahat's gone. It's just 2, yeah. So if z equals x equals 0, so let me go to Scribbler. Let me find Scribbler. Oh, yeah.
Hello.
Hello, yeah, you're back. See, I've missed
Yeah.
it. So we're just saying that's the equation, and we're just gonna set x equal to 0 to find out where it crosses the x-axis. So that's going to give us nothing plus 2 e to the 0. And what's e to the 0?
1.
Exactly. So times that by 2, we get 2. So it crosses the y-axis at y equals 2. Yep, straightforward.
So, sorry, what's the name of this? What was the name of this rule? The chain rule?
We haven't done anything yet. We haven't done anything. We haven't done rules. We're going to do the product rule. But all we've done so far is establish where's my there it is. Establish where it crosses the y-axis. That's all we're doing so far. Yeah. Straightforward. Okay. Quite a straightforward intro to this question. Where does it cross the y-axis to? Okay, so part B, show that C crosses the x-axis at x equals 2 and find where else it crosses the x-axis. So we can see it crosses the x-axis here and here. So the question is, where? So how would you figure that out?
Well, it's basically saying that that's the solution to the equation. So x equals 2, like make the equation 0.
Yes, exactly.
Find the other factor.
Yeah, so that's the key thing is we need to set y equal to 0 in this equation. The x-axis has equation y equals 0. So if you put 2 into it, it should give 0 as an answer. That's what it's saying with the first one. And how would we find the other coordinate where it crosses the x-axis?
You just put the x equals -2 on top of just use that to find the second equation, right? Like how you normally would. Oh, sorry, the second solution, how you normally would, right?
Yeah, so what do you mean by normally would?
As in you'd have the equation itself, you put the x -2 on top, and from there you work out the other solution using the method that you taught us.
Okay, yeah, I think I know. I see what you're saying. Yeah, okay, yeah, exactly. So let me go back to the whiteboard. So, excuse me, if I'll use that. So if we set the whole thing equal to 0, so y is 0 when it crosses the x-axis. So if we look at that equation, two things are multiplying, and the answer is 0. What does that imply? One of them must be
0.
0, yeah, because how else is the answer 0? And the thing about e to the minus x is that it's actually never 0 unless x is at infinity, because it looks something like that. So for any value of x, it's always a positive number. So it can't be e to the minus x. So therefore, it must be the quadratic 2x squared minus 5x plus 2. It asks to show that x equals 2 will give 0. So if you substitute in 2, we're going to get 2 times 2 squared minus 5 times 2 plus 2. And yeah, that equals 0 because it's 8 take away 10 plus 2.
Was it not x equals 2?
X equals 2, yeah, that's what I put in, yeah.
Oh, okay. Sorry.
And then as Rahat said, if we know one of the factors, I can find the other one. So x equals 2 means if the factor is x minus 2, because if x is 2, 2 take away 2 is 0. So the other factor will be, I need to have a 1 there to get minus 2. Oh, sorry, minus 1 to get plus 2. And then I need to get 2x squared. So I need to have a 2x here. And in the cross, we've got 2x times minus 2 is minus 4. And minus 1 times x is minus 1. So it's minus 5. So that lines up nicely. And that means that 2x minus 1 is the correct factor. All makes sense?
Yeah.
Yeah, so we factorize the quadratic fully, x minus 2 and 2x minus 1. Put that equal to 0. We know x is 2 for the first one. The other one is 2x minus 1, so 2x must be 1, so x is a half. Okay, so 2x must be 1 because 1 take away 1 is 0, and x is a half. Is that okay so far?
Yeah.
Yeah, it's quite straightforward, isn't it? Basically just trying to find out where two lines cross. We're trying to find out where this line crosses the y-axis, and then we're trying to find out where this line crosses the x-axis. That's all. All the usual stuff. It's our kind of fundamental algebra. Okay, so let's have a look at the next question, which is really the kind of point of this session, which is find dy by dx. So how would you differentiate this?
Well, you could like let x equal u.
Yeah.
Like so you differentiate the bit in the brackets and you do e minus x separately, and then you like put them together again.
Yeah, okay. That's a bit vague, but yeah, okay. Do this, do that together. Is there any particular rule we need to use?
Product rule,
Product rule. Yeah, why product rule?
because you're multiplying e minus x with something.
Yeah, if the problem here is that you can't really multiply these brackets out and get anything particularly different. It's factorized really. So you've got x terms and then you've got e to the minus x. So they're two different kinds of functions. And when you multiply two different kinds of functions together, they don't simplify any further. So the sort of best we can get here is this kind of factorized version of it. We could multiply it all out, but that wouldn't really benefit us. We just get more products. So brackets means multiply. So it's a product of two functions which are of a different kind. So we've got polynomial function, i.e. the quadratic, and an exponential function. If you multiply two different functions together, and you want to differentiate it, you're pretty much going to be using the product rule for that. So what is the product rule?
So it was u dx plus v dx.
Well, not quite. Rahat, do you know?
So you make the function inside u, so and then you what was it? Don't think I can quite remember.
All right. Visual display unit. That's what we're all looking at the moment. We're all staring at a visual display unit. Yeah, so
UDV.
Yeah, go
on. I remember something about VDU, UDV.
That's it. Yeah, visual display unit. So these are two different kinds of functions. So we give one the label u and the other one the label v. Okay. And the product rule, which is derived from just multiplying out u plus dv plus v times v plus dv. Sorry, u plus du times v plus dv, right? Gives us this what you just said, Rahat. Now, because it's a product and product is multiplication, what is multiplication?
Addition.
Addition. So that tells us that we need to have a plus goes v du plus u dv. It's kind of got a symmetry about it, v then du, u then dv. And it just comes from actually the middle part of the multiplication in a cross. In fact, I'll just do it to the side here, okay? So u plus du is being multiplied by v plus dv. You know how you have our function and you increase it a little bit and see what the change is going to be? Yeah. So the original function is u. So one of the functions is u, the other function is v. Increase them both by a little bit and see what the change is. Okay, so I'll multiply these out. Right-hand column is going to give du times dv. Then we've got the cross. So we've got u dv, v du, right? And then left-hand column, uv. Does that make sense from multiplying those out?
Yep.
Usual technique, right-hand column, cross, left-hand column. Okay. Now uv is the original function. It's u times v, which is what this is. So the change is going to be everything that comes after that, like normal. This is the change. We're interested in the change. the du dv is going to be something that's so small we can effectively ignore it. You know, we talked about dx squared. So these are two very small quantities multiplied by each other. So we can ignore them. So that we're left with this change, v du plus u dv. So that's the product rule. And this will tell us how to differentiate products. That's where it derives from. Okay. Does that make sense? That we recall that? Do you recall that, guys?
Yeah.
Yeah. Okay. So v du plus u dv. If you look in textbooks, it's actually the other way around, but I prefer to if it leads with the v du. So all you do is calculate v du. So we've labeled that u is this quadratic. So what would the derivative of that be? Yeah, come on, guys. How do you differentiate that?
So the 4x minus 5.
4x minus 5. Yeah. That's straightforward for you. And then for v, we've got e to the minus x. And we need to differentiate that. So dv by dx. Now this is actually a crossover with another rule. So we have to use another rule to figure this out. But for now, we might just say the result. So do you know what this will differentiate to?
Doesn't it stay the same? E minus x.
Yeah.
So it just.
Yeah. So this is what type of function is this, guys? Our favorite.
Composite.
Composite because composite because it's got e to the something, which is also a function. So it's a function of a function. E to the right, and the thing that's in the function in the Russian doll part is minus x. So we've got to differentiate that as well. So what's the derivative of minus x?
Minus 1.
Minus 1?
Minus 1.
Yeah, minus 1. Straight line gradient minus 1, isn't it? So we need to times those two results together. So minus 1 times by the thing that always stays the same, e to the minus x. So the answer is actually minus e to the minus x. Okay, and that's part of the chain rule, which is one of the next rules we're going to look at in this series. But for now, we're just going to mention the result that'll differentiate to that.
Yeah.
Okay, so now we just substitute all those four things into v du plus u dv, and that'll give us the derivative. So v is e to the minus x times by du, which is 4x minus 5, plus u dv. So u, 2x squared minus 5x plus 2 dv minus e to the minus x. That's what differentiates to. We can tidy that up a bit by putting that minus in front of the quadratic. So there we go. That differentiates to e to the minus x times 4x minus 5 minus the quadratic times e to the minus x.
You wouldn't multiply that out or take them away.
Right, that's a good question. That's what I was leading to next. Yeah, so we wouldn't multiply it out. No, why not?
Like you said earlier, you can't multiply really with a function.
You can do, yeah, but just that everything will be times by e to the minus x, won't it be? So before x e to the minus x minus 5 e to the minus x minus 2x squared e to the minus x minus 5x e to the minus x plus 2 e to the minus x. Yeah, so everything would just be times by it. And we prefer it to be factorized because it's neater. Yep, so remember we said about brackets that they have two meanings. brackets multiply, but also this expression is factorized. And we prefer the factorized state. And I think you can see, Ollie, that you can do a bit more to factorize this.
Yeah.
And that's what you're hinting at. Can we do anything with it? No? Yes? No? Maybe?
Maybe something like the quadratic.
What about it?
So you can factorize the quadratic further, maybe.
You could do if you want. You could do if you wanted to. We have done that, haven't we? So we could factorize that, yeah. And that should be massively valuable. The main thing to notice is that both brackets are times by the same thing. E to the minus x. Yeah.
All right.
So
So if you multiply the second bracket with the sign minus, and then you can like add the brackets together and have the x outside.
very
E
good.
minus x.
Excellent. Yeah. Because what is multiplication?
Just repeated addition.
Right. So if you multiply by e to the minus x a bit and multiply by e to the minus x by another amount, the total will be those two things added together because multiplication is addition. So
Right.
we could write it as e to the minus x and then do minus 2x squared and plus 9x because it's going to be 4x plus 5x and then minus 7.
Mm.
And there we go. Fully factorized.
Cool.
Any questions?
No.
Okay.
No.
If you're in the exam and you didn't factorize it fully, it wouldn't be the end of the world or anything like that. You probably get full marks. It wouldn't be like, oh, not factorized fully, therefore no marks. You know, that's not really the point. It's just a nice thing that we want to be able to do. Which leads us on to the next question. The next part of the question, because the next part of the question asks, hence find the exact coordinates of the turning points of C. So we want to find where the turning points or stationary points of this curve are. So we differentiated it. So that might be useful. So how would we find the coordinates of the turning points?
You need to find where the gradient is 0.
Yeah, we need to find the gradient of 0. Yeah, so we set the derivative, dy by dx, which is the gradient, the rate of change, change per step, 0. And because we've got it in this nice combined format of basically a quadratic and e to the minus x, we can solve for it easily. Whereas before, on the previous line, if you tried to solve for x here, it's a bit of a mess. It'd be quite tricky to do. So that's one of the benefits of factorization. It simplifies it, makes it easier for us to do things. Okay, so how are we going to find where x is from this equation?
Hmm. Would you mind saying that again?
Yeah, well, we want to find where x is, don't we? We want to find the turning points, stationary points of this curve. You said, I want to set, okay, so I'll set the derivative equal to 0. That'll tell you. So I need to solve this equation now and to find out what x is. How are we going to do that?
A bit like earlier where we said because minus x isn't going to be 0 because x is a real number. So expression inside the bracket should equal to 0.
Right, exactly. Same logic as above, which is they often try to help you in this way because we've already had this issue in part A or part B. I think it was part B, where you had to figure out what x was. Well, this is the same problem, isn't it? Same problem again.
Yeah.
Yeah, and they've helped.
Right.
So two things are being multiplied because of brackets, and the answer is nothing, which implies one of them must be nothing. But e to the minus x isn't nothing, unless x is infinity, which it isn't.
Yeah.
Basically, we don't tackle that. So it must be the other bracket. So we can write this quadratic equals 0. So we've got a new quadratic to solve. And to make our lives easier, what we'd probably be best doing is multiplying by -1.
Okay.
You don't have to. If you want to do a negative quadratic, you can do. But if we just multiply both sides by -1 at the same time as identifying it's equal to 0, it's easier to do. Yeah. Now, is this quadratic factorizable or not? Don't know, but chances are it would be. So if I just write it to the right here, draw a line. Above, it's two numbers that multiply to get 7. What could they be?
So 1 and 7.
Well, 7, because 7 is a prime number, isn't it? Right, so there's not many choices.
No.
Right, so 1 and 7. 1 plus 7 does not make 9, but that's not a problem because we're just going to skip to try and get 2x squared. So how would we get 2x squared?
Oh, sorry, 2x and x.
2x and x, exactly. 2x and x, yeah. So 2x and x or x and 2x? So let's try 2x and x. Okay, so the left-hand side is fine. Going to give 2x squared. Right-hand side is fine. It's going to give +7. Does that combination give -9x?
No, it should be the other way
around. Exactly. So it's going to be x and 2x. So we'll just quickly swap them around. And is that combination going to give 9x?
Yes.
It is if we choose the correct sign, yeah. So we've got 7 there, 2 there, 7 plus 2 is 9, but it's -9, so it's a minus and a minus.
Yeah.
So now check it again. Right-hand column is +7 because minus times a minus is a plus. Left-hand column is fine, it's not unaffected by this. And the middle is going to give -7x, -2x, which is -9x. So in A-level exams, that if it's a question about anything but quadratics, normally they're quite nice quadratics because they don't want you to spend ages trying to solve it. That's not the point of the question.
Yeah.
So we have x minus 1 times 2x minus 7 equals 0 because that's what the gradient is. So what is the location of the two turning points?
X is equal to 1. X is equal to like 3.5, 7 over 2.
7 over 2, yeah, 3.5, exactly. So if we look back at the graph, it's just going to be a bit rough to scale, but 1, so it cuts it a half here. Remember, x was a half. This was 2. So this value here we found is 1, which seems reasonable enough. Half, 1, 2, yeah, okay. We want to also, check our answers, make sure they make sense. If we got an answer of -7, we're like, no, I don't think that's correct. It's not. There's no turning point there. So it's worth checking the answer and see does it make sense. The other one was 3.5, 7 over 2. That seems reasonable as well. Yeah. So I don't know these are the correct answers for sure in that sense because I looked at the graph, but I can vaguely see that they might be correct.
Okay.
Not ridiculous answers, they're not outside the realms of possibility. Whereas minus, we got -7, so it would be. We're like, well, that doesn't make sense.
Yeah.
Okay, so that's it. So that's a kind of nice little question using differentiation, finding where the gradient is 0. The function that we had to do that with was a product of 2 functions. So we've got to use a product rule. And and that's it, guys. The other examples all involve using the other rules, the other examples I could find. So I don't want to cross-contaminate the video, just make it about the product rule, not the rest of the rules, okay? Because the next 2 videos will be about those 2 other rules. Yeah. So
Okay.
to make it uniquely about product rule. And we're using quite common skills, you know, we're using algebra in parts A and B, trying to find out where 2 lines cross. Where does a line cross the y-axis? Why does a line cross the x-axis? Just algebra, isn't it? Then we're differentiating by using product rule, and then we're trying to find, very commonly trying to find where the turning points are. So we equate it to 0. And once you equate to 0, you can solve. And what do you solve? A quadratic. So it's all the same skills, you know, solving a quadratic, trying to find out where 2 lines cross, differentiation. So it's quite a nice example of a question which uses many of the skills that you're going to need. Any questions about any of that?
No, it's fairly straightforward.
No questions.
No questions? Okay, so I'll stop recording now.